After more than a decade of slow progress, delays, redesigns and changing plans, the Dream Chaser spaceplane has finally cleared its last major ground milestone before its first flight into space. Sierra Space has confirmed that Dream Chaser has completed electromagnetic testing, high-speed towing trials, communication checks, and full landing recovery rehearsals. These were the final demonstrations needed to prove the vehicle is ready for real space operations. At Kennedy Space Center, the Dream Chaser was carefully placed inside a specialized facility designed for advanced testing and evaluation. Here, a team of engineers conducted rigorous tests to see how all of the spacecraft's electronics would respond to a wide range of electromagnetic environments, simulating the harsh conditions of space. Every spacecraft, including Dream Chaser, generates its own electrical signals through its complex network of wiring, computers, and onboard systems. If these signals interfere with critical navigation or communication software, it could cause the mission to fail instantly, putting both the spacecraft and its objectives at risk. Through these comprehensive tests, Dream Chaser demonstrated that all of its computers and control systems can operate together smoothly, without causing any interference, an essential requirement for safe and reliable orbital flight, ensuring mission success. Another important test involved pulling Dream Chaser across a runway at high speed using a heavy truck. This simulated the exact forces it will experience during an actual runway landing. Engineers tested the landing gear, steering, braking system, and automated controls together in real-world conditions. The vehicle remained stable, and the landing gear behaved exactly as designed, demonstrating that Dream Chaser can safely land like an aircraft after returning from orbit. With these steps completed, Dream Chaser will now go through its final acoustic test, which simulates the intense vibration and deafening noise of launch. If it passes, the spaceplane will be cleared for its first mission in 2026. It will launch atop a Vulcan Centaur rocket and land at Vandenberg Space Force Base in California. Dream Chaser stands out from current spacecraft because of its design. Most modern spacecraft, like SpaceX's Crew Dragon or Boeing's Starliner, are capsules that re-enter with heat shields and parachutes before splashing down in the ocean. Recovering them requires large ships, crews, and extensive refurbishment. Ocean landings also expose the hardware to salt water, increasing long-term maintenance. Dream Chaser avoids these problems entirely. It launches vertically like a rocket, but returns horizontally like an airplane. The entire descent and landing are fully automated, with no pilot needed. Its smooth runway landing allows it to return delicate scientific experiments without the rough handling and sudden impacts typical of capsule landings. And because it lands on a runway, it can be rolled into a hangar immediately for inspection. No ships or ocean recovery required. This first version of Dream Chaser is designed for cargo missions. It can carry up to 5,000 kilograms of pressurized cargo and also includes a detachable module called Shooting Star for unpressurized cargo and power. During re-entry, the Shooting Star burns up in the atmosphere while, the main spaceplane returns intact for reuse. The Dream Chaser spacecraft features a unique lifting body design, which means its entire shape is engineered to generate lift during atmospheric re-entry, rather than relying on large traditional wings like most airplanes. This allows for a smoother, more controlled descent and landing, making it ideal for returning sensitive cargo and experiments safely to Earth. The concept of the lifting body actually dates back to NASA's pioneering research in the 1960s and 70s. During this era, experimental aircraft like the M2F2 and HL-10 were tested to explore new ways of re-entering Earth's atmosphere, and these early efforts would later influence the design of the space shuttle. Building on this legacy, NASA developed a small, crude space plane concept in the 1990s called the HL-20. The HL-20 was designed to be a safe, reusable vehicle for transporting astronauts and cargo to low Earth orbit, and its innovative shape became the foundation for future commercial spacecraft. Sierra Nevada Corporation recognized the potential of the HL-20 design and adapted it, making significant improvements and modifications. Their work eventually led to the creation of the Dream Chaser, a modern spaceplane capable of both crewed and uncrewed missions. Today, the Dream Chaser program is managed by Sierra Space, which has become a standalone company dedicated to advancing commercial spaceflight. Their ongoing work continues to push the boundaries of reusable spacecraft technology. Originally, Dream Chaser was planned as a crew vehicle. When NASA launched the Commercial Crew Program, Dream Chaser competed against SpaceX's Crew Dragon and Boeing's Starliner. Many believed Dream Chaser had strong potential, but while SpaceX made rapid progress, Dream Chaser faced funding gaps, redesigns, and long delays. Eventually, NASA selected only SpaceX and Boeing for crew missions, and Dream Chaser was reassigned to a cargo-only role under NASA's resupply contract. So SpaceX quickly advanced Dragon, which, flew its first uncrewed mission back in 2019, and then its first crewed mission in 2020. Since then, Dragon has really become the primary way NASA transports astronauts to the International Space Station, with dozens of successful missions under its belt. Boeing, despite actually receiving more funding than SpaceX for its Commercial Crew Program, has faced a series of persistent and high-profile issues with its Starliner spacecraft. The company was once seen as a reliable aerospace giant, but its journey to send astronauts to the International Space Station has been anything but smooth. Starliner's first uncrewed test flight in 2019 failed to reach the ISS due to some surprisingly basic software errors. The spacecraft's onboard clock was set incorrectly, causing it to burn too much fuel and miss its planned orbit. This embarrassing mistake forced Boeing and NASA to reevaluate their testing and review procedures. The second uncrewed test flight, which took place in 2022, finally managed to dock with the ISS. However, it wasn't a flawless mission. Several of Starliner's thrusters malfunctioned during critical maneuvers, raising new concerns about the spacecraft's reliability and safety for future crewed missions. Then, in 2024, Starliner's first crewed test mission did successfully reach the space station, marking a major milestone. But the celebration was short-lived. Helium leaks and additional thruster failures were discovered, making the capsule unsafe for the astronauts' return journey to Earth and casting doubt on the program's future. As a result, NASA made the difficult decision to order those astronauts to return home aboard a SpaceX Dragon capsule instead. This move underscored the agency's concerns about Starliner's safety and reliability, and highlighted SpaceX's growing dominance in crewed spaceflight. The Starliner program has since faced indefinite delays, increased scrutiny, and expanded oversight from NASA. Boeing now faces an uphill battle to restore confidence in its spacecraft and prove it can safely carry astronauts to and from the ISS in the future. Dream Chaser, meanwhile, isn't competing in the crew market, for now anyway. Its job is to deliver cargo and return experiments with a smooth, controlled landing. Its reusability could reduce long-term costs if refurbishment proves easier than capsule restoration. Its first flight will be a demonstration mission that focuses on its launch, orbital operations, and runway landing, not ISS docking. If successful, Dream Chaser will begin performing full NASA cargo missions afterward. This upcoming orbital test will be the most critical moment in Dream Chaser's entire history. Until it completes the full journey to orbit and safely returns to Earth, its capabilities remain unproven. The real test begins when it meets the extreme heat and forces of atmospheric re-entry for the first time. That's it for this video. Thanks for watching, and I'll see you in the next one.